Well, good afternoon, everybody, and welcome along to Data Platform Downunder. For those of you who don't know, my name's Warwick Rudd. In conjunction with Martin Catherall, we're your hosts for the Data Platform Downunder virtual meetup group. In this month's session, or I shouldn't say in our first session for this month, we've got Torres speaking to us from Malta, and he's going to talk to us about the secrets of storing blobs in a database. Now, this session is being recorded and will be made available on our YouTube channel, Data Platform Downunder, and that should go up either today or tomorrow once the session has completed. If you've got any questions at all during the session, feel free to raise your hand so that I can know that you've got a question, or put it in the chat window and we can get you to ask those questions to Dennis either throughout the session, depending on when it's appropriate, or at the end of the session. So with that, I'll hand over to Dennis and we'll be able to get this session running.
So, thank you very much. So I will be talking about secrets of storing blobs in a database. My name is Torres. I'm a data platform MVP with some Microsoft certifications, and I'm the leader of Malta Data Platform User Group. On the right side, you see my contacts. Feel free to get in touch and connect. It will be a pleasure to keep connected. So, our agenda today. We have old data types and new data types. Why should we replace the old data types by new data types? How rows are stored, how text fields work, how varchar max fields work, solving the problem, because there is a problem. We'll see a problem related to the varchar max fields. Then we talk about more advanced subjects like file string and file table. So, lob types. What's lob? A lob is an acronym for large objects. When we need to store a large object, we use lob types. Old lob types were text and image. And the new lobs replacing the old lobs are varchar max and var-binary max. And why should we replace the old ones by the new ones? Text fields are deprecated, so they may be removed on some future version of SQL Server. Although Microsoft already said they are not planning to really remove deprecated features. So do you really need to replace them? That's the point. It's not only about the feature being removed. It's about that every new feature that is created in SQL Server may not be compatible with text fields. This kind of fields requires special handling, and new features are not focused on these old fields that are already deprecated. So you find many new features that only works with the new data types that replace the old ones. So we need to replace the text fields, old text fields, by varchar max fields. And in fact, you may feel at this moment that I'm talking about a very old thing, about something from the last century, because nowadays most people already did this replacement, already replaced the text field by the varchar max fields. But we need to understand a bit more about the consequence of this replacement and how to manage this replacement correctly. To understand this, we need to understand how rows are stored. How the rows are stored inside the SQL Server database. So, that's the structure to store a row. The database is a file, MDF file. We create the database, we are creating an MDF file. And the MDF file is, in some ways, similar to a disk. Imagine about a disk. You include files in a disk, but how the disk controls where the files are? The disk needs to be formatted, and this format breaks the disk in areas and sectors. So you will know where each file is inside the disk, having an index page in the beginning, knowing where everything is. What happens inside the MDF file is very similar. It's quite the same. The structure is different, of course, but it's quite the same. The MDF file is structured in extents, and each extent is a set of 8 pages. Each extent is a set of 8 pages. And the page has 8 kilobytes of space. So each page has 8 kilobytes and each extent has 8 pages. The rows will be stored inside the pages. One rule that SQL Server follows. I will not talk about exceptions now. Let's believe the rule until we discover the exceptions. One rule that SQL Server follows. One record can't spread across multiple pages. So 8 kilobytes is the size limit for a record. One record can't have more than 8 kilobytes. It's a limit. And how text fields are stored? Well, we know that text fields they can contain much more data. A text field can contain up to 2 gigabytes of data. And take a look on this table. We have an ID, name, and an L field, abbreviation of lob field of kind text. So inside the data page that has the 8 kilobytes of space, we will include the regular fields, ID and name. But each record can have up to 2 gigabytes of space on the L field. How will fit 2 gigabytes inside an 8 kilobytes data page? We can't. We can't fit this. How do we solve the problem? Simple. We use a pointer. In row pointer inside the row on the data page, and this pointer leads us to another structure, a different kind of page inside the MDF file. This different kind of page is called lob data page, lob of lash object. So we have the regular data page and the lob data page. Our regular data or data types with regular size will be contained in the data page, but the lob data page will contain the lob data, the large objects data. But it's not so simple. Of course, we can't store 2 giga in a single page. A single page has only 8 kilobytes. So what we have is a tree structure on the lob data page. So from the lob data page, we'll have a tree with many lob data pages containing the data for the records. So when this information needs to be recovered from the database, we need to read from out this structure. And why is this important? Let's imagine that I make a select ID name from table 1. I'm selecting ID name from table 1, and I'm not selecting the lob field, the L field. What happens? By only including in the select the ID and name, I don't need to scan the lob data pages. I can scan only the data pages. So I will read way less pages than if I had included the L field. And this highlights one very important detail to developers. Developers sometimes don't fully understand the impact of adding a simple field more in the query. They don't understand how one single field more in the query can create so much impact. This is one example. There are many other examples in other situations. This is one example of how one single field can cause a huge impact in a query. So, if the developer makes the select query wrong, and there are developers that, oh, let's make a select star. Let's get all the fields and then we decide what we need. And all this is a terrible practice because we are reading a giant field that you don't need, and it's not only about being a giant field. This field is a pointer to other places in the disk that will be need to be loaded into memory. So you are creating a lot of more work to SQL Server, and maybe you are not even using this field. So this highlights quite well the importance of selecting only the fields that you need, because one extra field in a query can mean a huge difference of performance. So in this second query, the data page and the log page are scanned. Let's see a demonstration about this. I have here a virtual machine. All my demonstrations are in this virtual machine, and I have SQL Server here on this virtual machine. I will start illustrating how the text field works. I will create a database called testdb. Drop if it exists, then create. So I'm creating from very beginning and use the database, use testdb. And now I'll create a table called lob1, that means large objects 1. I will have an ID, int identity, not null, primary key, a name just to put some content on the table, and the L field, the big field, the lob field. And let's create this table. So I'm creating this table, and now I'll insert data inside this table. Mind that I'm using the goal statement with a number besides the goal statement. This is the goal statement is not a server statement, it's a client statement. The goal never goes to the never went to the server, it's never sent to the server. So it's a client statement. Using this number besides the goal statement means that I'm asking the above statement to be repeated 100 of times. So I'm inserting this record 100 of times. And the other record below, I'm inserting again 100 of times. So the difference is the size of the lob field. I'm putting some record with 900 characters and other with 2000 characters. So let's execute. and I'm inserting 200 records inside the lob1 table. Okay, how will I discover how this table is being stored? So we need to go and use system objects. In this case, I'll use a system function. This system function is called sysdmdb database page allocations. So these system functions allows me to check the page allocations of something, some object, for example. The parameters are the ID of the database. So I'm using the function the BID to recover the ID of the database. The ID of the object, so I use object ID to recover the ID of the table. Index and partitions. If I'm using partitions, this would be important, but since I'm not using partitions, this is a very simple table. So I'm putting 1 and 1, clustered index and first partition. And I'm asking to get detailed information. There are differences on the amount of information that this function returns. I'm asking for the detailed option. Then what I want to see is the kinds of page and amount of each kind of page. So I'm grouping by allocation unit type desk and page type desk and recovering a count of this. So let's execute this query and understand how our table is stored. Here it is. Oh, sorry. Oh, yeah, sorry. I need to open one very important tool I use for Zoom. Okay, now it works better. So I will execute again this query. Here it is. Let's analyze what we discover from this result. First, allocation unit type desk. We have in-row data and lob data. So we have two types of allocation units being used by this table that I just created. So we have the regular data pages, which are the in-row data. And we have the pages dedicated for large objects, which are the lob data pages. So we have two kinds of allocation units. Inside the in-row data, we have one data page. It means that all the records that are inserted, it was 200 records. All the 200 records are inserted only got one single page. They fit in one single page. But what about the lob field? The lob field is not included there. For the lob field, what was included is a pointer to another place, to the lob data pages. All the 200 records fit in one single page. On the lob data page, we see a different kind of page, which is called text mix page, and we have 54 text mix page only to hold the lob field, only to hold the text field. And we can notice some more details. For example, I have explained that an extent has 8 pages. So in the in-row data, we used one page. How many pages are left? from one extent, we have 7 pages left. So there are 7 pages where the page type desk is null. This means that they don't have a use yet. They were not assigned a use yet. They are empty and they don't have a use yet. They will once the table grows. And on lob data page, we have two pages with null, means 2 pages on lob data page were not used. To find this number, we need to find the multiple of 8. And we will notice that we got many extensions, but 2 pages on the last extension are not used yet. And finally, we notice that each allocation unit type has an IAM page. What's IAM page? Is the index allocation map. The index allocation map for this allocation unit type. And this is an index specifying which page, which extents are being used or which extents are not being used in this allocation unit type desk. So each one has one single IAM page. We have one for enroll data and we have one for lob data. Okay, so we went deep now. Okay, we got details about the page storage for this table. Why is this important? Let's analyze this. I will turn on one feature on this session called Set Statistics IO On, so I can compare 2 queries. The first query here is not retrieving the L field. The L field is not being retrieved. So I execute, and what the statistics IO tells me is the number of reads that I have. So we have 3 logical reads. Only 3 logical reads to retrieve in order to retrieve the data from the ID and name. But what happens if I include the lob field in the query? Let's try again and include the lob field. What happens? So I'll check the message and you'll see, oh, it's the same logical read 3. No, it's not the same. It's just that the lob reads are not included as logical reads. They are shown in separate. So we had 665 lob logical reads. 665. And we know we have 200 records. It means for each record on our 200 records, there was the need to make 3 reads. Read the IAM page, read the root lob data page, and read the data page for the data. And some additional reading that went to 65 additional pages. Some additional reading for that. So we are seeing that just by including the lob field, just by including this lob field, we are affecting a lot the performance of the query. the performance of the query becomes way different just by including this field. Okay. So we saw how the text fields work. That's the way the text field works. Let's get back to our PowerPoint. And how varchar max fields are stored. So we are replacing the text fields by varchar max fields. Not only replacing, probably most of you already replaced, believing that since Microsoft said varchar max is better, so let's go with it. What's the result? How varchar max fields are stored? They only use lob data pages if the content is bigger than 8 kilobytes. If the content is not bigger than 8 kilobytes, they will try to fit the content inside the data pages. What will happen? What will happen is that we will be fitting very large fields, very large objects inside the regular data pages of the table. And this can cause a performance problem, a considerable performance problem. Let's see these two examples. I'm showing an example of two different tables. And these two different tables, on these two different tables, we are making a select ID and name. In none of these tables, I'm including the large field, the lob field. I'm only querying the ID and name. The first one, we already saw the result. The result is that we get 3 logical reads because the pointers are not followed to the lob data page and the lob data pages are never retrieved. That's great. That's what happens with the text field. But with the varchar max field, it's different. As I just said, the varchar max field by default stores its content inside the page. So as a result, we get a huge amount of logical reads, 40 logical reads on this example. Why? I'm not reading the lob field. It doesn't matter because in the way it's stored, the lob field is getting space inside the regular pages. So to read the same amount of records, we need to read more pages because we are wasting space inside the regular pages. And this leads to 40 logical reads. So what you are seeing here on this slide, illustrated on this slide, is that when you just replace text to varchar max, believing that Microsoft is right. So Microsoft is saying that we should replace, let's replace, and that's it. You are losing a considerable amount of performance. You are losing a considerable amount of performance. So how do we solve this problem? How do we solve this problem? Most people, most DBA don't know this small trick. And this is absolutely necessary when dealing with varchar max fields. Every table with varchar max fields should use this feature. What is this feature? It's a table option. Yes, a special table option called large value types out of row. To enable this table option, we use a store procedure, sp table option. sp table option, then the name of the table, _value types out of row, true. When we enable this feature on the table, this changes the behavior of the varchar max. Instead of trying to fit huge amounts of data in the page, the varchar max will by default just use a pointer and use the lob data page, exactly as the text field did before. Exactly as the text field. So in this case, after using this option, we will see a similar result as if we were using text fields. So we should replace text by varchar max? Yes, because text is deprecated. There are a lot of features that don't work with text fields anymore. But in order to make this replacement in a correct way without losing performance, we need to enable the table option _value types out of row. If we don't enable this, our queries will be way slower than they could be. And in this case, we return to the original result that we can select just the ID and name, not including the lob field in a query, and we'll have just 3 logical reads. Let's see a demonstration about this. So I'll get a second example. You use the testDB. Inside testDB, I'll create a second table, table lob2, ID, name, and the L field. And in a very similar way, I will insert 200 records on this table. So let me adjust the zoom. So I inserted 200 records. Now let's check the allocation of this table. Is the same statement than before, changing the name of the table, but it's the same statement I used before to check the allocation pages of the table. And now what we discover? We discover that by using the varchar max field, we don't have lob data pages. All the huge content of each record were inserted inside regular data pages. And as a result, we have 38 data pages. That's a huge amount of data pages. That's too much. That's a huge amount of data pages. So how to solve this problem? We talked about this, the solution for this problem before. Oh, just now, there is one more insert here as an example, just to show that. In this case, I'm inserting records with 9,000 characters. What this means? 9,000 is bigger than the amount supported by one single page. So in this situation, when we try to insert something that is bigger than the page limit, in this case, the lob data pages will appear. So now I have lob data pages, but the lob data pages are being used only for the ones that were really very big. But the other ones are really wasting a lot of space in the in-row data pages. And the result of this is that we will make a query. Oh, I don't have the queries here. Let me copy the queries. Sorry, I missed the queries there. So I will turn on set statistics IO on. I changed the name of the table because now I'm dealing with lob2. And with statistics on, let's select ID name from lob2. And the result is that we have 41 logical reads. The content of the table lob2 is exactly the same content of the table lob1. And the query that I executed is the same. But the way the fields are stored made the result of the query on lob2 spend 41 logical reads, while on the old table it was spending only 3 logical reads. And of course, if I include the L field, it will not be better in any way. I have the 41 logical reads, and I also have 421 lob logical reads. So what we are seeing here is how to just put a varchar max field in our tables create a huge problem of performance. The performance is suffering a lot on this example. So the performance is suffering a lot on this example. So let's see the solution for this. I already talked about the solution. And let's build the solution. I'll drop the table lob2 and build a new table lob2. The difference now with this new table lob2 is that I use the spdb option and I will enable the option lash value types out of row. This option needs to be enabled for every table that has varchar max fields. This option needs to be enabled. Now I insert the 200 records is the same 200 records. The same 200 records. And I'll check the allocation of the pages for this table. So now with the allocations, we can see now I have a result that is very similar to the result that we have achieved before with the text field. Now we made the varchar max field work as the old text field. So the data page is just one page, and all the big fields, the lob data fields, are on lob data pages, on TextMeet pages. I included this query here to check. You can check which tables have this option enabled or don't have this option enabled. So I'm showing the tables with the option enable or not enable. You can use this query in your database to easily find tables that may have problems, maybe with this option disabled. And let me get the last queries that I used. I used these queries. Let's execute again on the new window. Set statistics IO on. Then I select ID and name, only ID and name from the lob2. And now I get a result that is similar to the text field. So now I get back to read only 3 logical reads. Tell me. What you tell here, it will stay here. How many of you are really using the last value types out of row in your database? How many of you may have many varchar fields, varchar max fields that don't have this option set? Don't worry, they will not spread this. Peter.
If you like, Peter, you can unmute yourself and ask your question of Dennis. We might come back to Peter's question if you'd like to continue, Dennis.
Okay, it appears everyone is a bit shy to confess they have varchar max fields with this problem. Peter just said yes, he is using varchar max fields. So it's already something that you can immediately improve in your environment. You can just set this database option. Then when you set this database option in an existing table, you can choose how you will proceed. If you just set this option, what will happen is that the data will get into the correct place according the change that happens in the table. It will be a slow process. The data will be slow in going to the correct place. But if you would like to transform your table immediately, after setting this option, you just need to rebuild the clustered index. Rebuild the clustered index and the table will be in a new storage format. The varchar max fields will be corrected and your queries will have better performance.
So, Dennis, did you
Yeah.
see Anil's question?
I'm seeing the head edge asked if since they are using full test index over these fields, if they can really use the last value types out of row. Yes, you can. The both features are not related. They are not related. And it's very good that we are using full test indexing over the big fields, over the varchar max fields. And By setting this option, large value types out of row, on the tables, you improve all the performance for all the queries that don't include this field on the query. And what you need is that all the developers need to follow best practice. Only query the fields that they need. Once again, this is an explanation for many best practices, like, for example, why the developer shouldn't use a star, a select star, because this, what I'm showing, is only one single example of the impact that just an additional field can have in a query. Risk disadvantage. I don't see any risk or disadvantage. There is only disadvantage if if your environment has mistakes over mistakes. For example, let me give you an example. I was checking one new environment just a few days ago, and I found many tables with varchar max fields. And these varchar max fields, these tables didn't have the large value types out of row enabled. However, I look at the name of some of these varchar max fields, and they were like name. Some of these fields were contain things like name, and the developer included the type as varchar max. This is a mistake. So the developer did a mistake from the beginning, including a field name as varchar max instead of giving a size to this field. This is the first mistake. Then what happens? If you enable this option in an environment that I already have this kind of mistake, the query from the developer may be slower because name is usually a field that may be included in all the queries the developer does. So if this is included in all the queries the developer does, the fact that the query will require to follow a pointer to another place will make the query slower. The large value types out of row, they are very good for fields that are not used on all queries. And that's something natural. If you have a good modeling, varchar max fields are used on only very specific queries, not all queries. I never use it on all queries. So if the modeling is good, it will work. But if you have a modeling problem, wrong data type put on the fields, then you will create a performance problem by enabling this. What should solve a performance problem can end up creating a performance problem. So it's a mistake over a mistake. If your environment has this kind of modeling problem, you need to be careful. Then Mike made an interesting question. What if your table has no clustered index? How do you immediately force the varchar max blobs to lob page? Simple. Tables that don't have a clustered index, they are called heaps. We use the name heaps for tables that don't have a clustered index. And heaps also can be rebuilt. You can make a rebuild over the index, over the table, directly on the table instead of the index. And the heap will be rebuilt. But this question hides other problems that you may have, because cluster and index help a lot on the maintenance of the tables, while heaps don't help on the maintenance. Heaps create ghost records and other broken links among records, and they don't fix it by themselves. And the heap will becoming slower, 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 according the amount of ghost records and broken links that the heap contains. So this rebuild of the heap is something that needs to be regular done. And if it's not being done, you have another problem of maintenance besides what I'm explaining here. Yeah, great. Great. The maintenance that you usually do, the rebuild for a heap, solves the problem as well. It's just a matter of rebuilding the heap. Just that. Okay. Let's go ahead. Now we talk about file string. Until now, I was talking about string values, large string values, up to 2 giga string values. Okay. But what if there is not a string value? What if this is a binary value? What if I want to store an image inside the database? What if I would like to store a PDF inside the database? What would happen in these cases? Then, let's talk about storing files and what's the best practice to store files. Most people think that we have only two options to store files. Or we store the files inside the database, or we store the files outside the database. Most people think these are the two options, and there is no escape from that. And both options have problems. Both of them have problems. In the database, this means that you will be inserting huge amounts of data inside the MDF file. This will create fragmentation inside your MDF file, and it will make more difficult to manage the storage of the MDF file. It will be more difficult to ensure the performance of the environment if you are storing files inside the database, inside the MDF file. Outside the database. What means storing something outside the database? Is the possibility to include, for example, we are storing files. So in the database, in our table inside the database, we include a link to where the file is. And then the file will be stored outside the database. This solves the previous problems that we talked about storing inside the database. Sure. But this created an external dependency. We are adding one more item, one more element that will be an external dependency, is the storage by itself. In the database, in the table, you will store a string that will be a link to a storage, and the presence of the storage will be another dependence on the solution. So when you are planning your environment, when you are planning the scalability of your environment and so on, you need to be concerned. Sorry. You need to be concerned about the database and the storage. So we have one more potential point of failure. And this will bring quite some work, additional work to the planning phase. And the application needs additional access to the dependency. The access to the dependency will be on the application level because the database will return to the application a string. This is the path to access the file. You will access the file using this path, and that's it. That's what the application, the database will do. And then the application needs to have access to the storage. What happens if you want to move everything to the cloud? What happens if you want to move things from one place to another? So you need to be sure that wherever the application is, the application needs to have access to the storage. What if it doesn't? The first option is storing in the database. If you want to move things, you move the database, and that's simple. You move the database and you change the connection string. But on the second option, if you want to move things around, you will need to ensure that the storage as a dependence is moved correctly, and the application will be able to access the storage correctly using the links that the application will receive from the database. And it makes more difficult to synchronize content among the database and the storage, because let's say that we have a record that is deleted. The file may be left on the storage, forgotten, and the record about that file may already have been deleted on the database. So it's difficult to keep the synchronization. It's possible, but it's difficult. So both methods pose a challenge. We don't have a middle way to solve this problem, or we didn't have, but now we have, is the file string. I'm saying now, but file string is a feature that appeared in 2008. SQL Server 2008 brought file string with it. What's the idea? We will set an attribute on the max field. In this case, var binary max. We will set a new attribute for these fields. The attribute will be file string. And by doing this, the operation system will become responsible for the file storage. So the files will not be inside the SQL Server database anymore. SQL Server will delegate the storage task to the operating system. So for the client, for the point of view of the client will send files to SQL Server and will read files from SQL Server. But behind the scenes, SQL Server is sending the files to the operating system. SQL Server is not saving these files inside the MDF. We use a special file group inside the database to store this. is a special file group because usually a file group contains files, the MDF files, the regular data files for SQL Server, but this file group will not contain files, not the MDF files. It's a special file group. So this is the halfway solution. This is a halfway solution that solves the problem of both previous solutions. SQL Server is responsible for the file. Yes, it is. SQL Server is responsible for the file. So if you need to move things around, put SQL Server in the cloud, move the application from one place or another, the application has no idea where the storage is and don't need to have any idea about where the storage is. SQL Server is responsible for the storage. But the storage is not being made inside MDF files. SQL Server is delegating the task to the operating system. So the problems of both previous solutions were solved by using file stream. We need to enable file stream in SQL Server Configuration Manager. So the instance of SQL Server needs to have permission to use file stream. Let's see how this works. How this feature works. So, let me close these files that I already used. Let's check the SQL Server Configuration Manager, SQL Server Services, and here on SQL Server Services, I need to ensure that file stream is enabled. Thinking. Finally decided to open the properties, and we have here the option file stream. So on the configuration manager, we can enable the file stream. It's like we are defining a permission for this to be used on an instance level. Then I enable file stream. I can enable file stream for I/O access. Allow remote clients to access file stream data? Yes. And mind this name, MS SQL Server. This name is quite important because later we will understand where these names will fit later. Windows share name MS SQL Server. Okay, we can customize this now, but I will not. Okay, so file stream is enabled in this instance of SQL Server. Let's restart the instance. Okay, the instance is restarted. Now I will open our next example, file stream. enable file stream on the SQL Server Configuration Manager is not enough. We still need to enable file stream on the server level. There is a configuration called file stream access level. File stream access level. So let's check this configuration. So we see that this configuration is disabled. The file stream access level is disabled. So let me confirm the database is here. The database that we will use. So I'll change the configuration of file stream access level. 0 is disabled, is the current one. 1 is enabled for access with TSQL. 2 is enabled for access with TSQL and Win32. Win32 is a series of APIs that can be used to access file stream. But this is a very complex subject. I will not go deep on this. Okay, the database that I'm using is DB test. It seems that I don't have it here created. So first, let's change the configuration. Change the server configuration. That's it. Now I will execute the check of the configuration. Now it's run value 2. So now file stream is enabled. So we have 2 levels of enabling file stream. We can enable file stream first on the level of SQL Server Configuration Manager, and then later we need to enable file stream on the level of the server configurations. We need to enable on both levels. Let me create the database, create database db test is the one that we will use for our file stream tests. It's done. So I have here a database db tests with the full configurations because I haven't included any special configuration for the db test. It's here. The full configuration. Here I can check files, and I have here db test and db test log. Great, great. Now I mentioned that file stream is configured by a special file group. Yes, true. We need to add a special file group to the database. I'm calling this file group FG, and we set this file group with the statement contains file stream. This makes this file group becomes special, becomes a file stream file group. Then inside this file group, I will configure a file. Sorry. I'll configure a file. Add file fs file, and I'm including a path. But I'm not really pointing to a file. Let's check my disk. I have here the folder Downunder, and I have here the folder files, and nothing else. There is nothing inside the folder files. So this fs will be created by this statement. So I'm adding this fs as if it were a file to the file group fg, which is a file string. So let's add this. Okay. So let's take a look again on the DB test on the Y, see how it's configured. So file groups, we see that we have one file string file group. Is the default for file string. And files, we see that we have the fs file that points to the fg file group, which contains file string data. So we configure the database structure to contain file string data. How is the folder now? Take a look. Now inside the files folder that we already had, SQL Server created an FS folder. So we have now an FS folder, and we have some files inside the FS folder that are, let's call these internal files for SQL Server. We don't need to handle them directly. Okay, getting back to SQL Server, now I'll create a table. Create table categories. The table categories will have an ID, category name, and picture. The picture representing the category. The picture representing the category is of kind var binary max. So we will have a var binary max picture, but to ensure this will be stored as file string, we just set the attribute file string. Is this enough? Nope. Nope. The ID of the table needs to be a unique identifier and needs to be marked as row gid co. Is an attribute of an ID, an identifier of a row, unique identifier of a row. The full set as a new ID, so we'll create a new gid for every record inserted, and this ID is the primary key. But now I can create a table. So let's create the table categories for this database. Oh, sorry, I'm on the wrong database. Of course, I need to be on the DB test. Where is it? DB test. Then I will create the categories table inside the DB test. And what happens with the folder? I had the folder fs before, and now inside fs I have a folder with GUID. This GUID represents the table that I created. And then I have another folder containing another GUID. Why? Because I could have inside the table many file stream fields. So for each field, I have a GUID representing the field, and then the content of the field, the file stream field here. But there is nothing there. Okay, there is nothing. So let's insert something. Let's finally insert something and see the result of this. I have a database Northwind here. most of you may know the very old Northline database, and the Northline database has a table called categories, and this table has a picture of the category. So what I'm doing is that I'm importing the data from the categories table in Northline to my file string table in this database. So let's insert, and I have 8 records inserted. Let's see the result on the disk. After 8 records inserted, and we have a total of 8 files. So each category picture is stored inside this folder. But I don't need to care about this folder, because my application will be able to read the content from SQL Server, and SQL Server will return this content as a blob field. But by storing this with the operating system, we don't need to care about the management of this huge amount of data inside the MDF files. So it's making the MDF more specific for the data itself. And huge files that need to be stored will be stored by the OS, by the operating system. So let's see the categories. I can see here the picture. He's in binary, of course, but I can see the picture here. One application could read this picture and show the picture. I can check the configuration, file string configuration for this database. In fact, I'm reading from our database and checking transaction access and non-transaction access for file string. File string is enabled, but no one is using non-transaction access. No one is using non-transaction access for now. Okay, so we used file string. That's good. But we can go one step further. We can still go one step further. We have file tables. File string was created in SQL Server 2008. File tables were introduced one version later in SQL Server 2012. So it's not a new feature. It's something quite old, but many people doesn't know that this feature is there. So it's based on file string. So the feature of file table is based on file string. Depends on the file string to works. So we can create a table in the database that will match the files in a folder in the disk. And we can link SQL Server with a folder in the disk. We have a table linked to a folder. That's absolutely great to manage documents that need to be sent to SQL Server, and SQL Server needs to react to these documents. Let's see a demonstration about this. So, file table, when used, has some additional requirements. First, the requirement of using non-transacted access. We just saw that the non-transaction access was not enabled in any database, but for file tables, it needs to be enabled. And we need to add a new name that we will call directory name, and I will call this directory name as file table. So let's remind some details. When I configure the file stream on the configuration manager, I defined the share name as MS SQL Server. Now, for our database, I will define the directory name as file table. So let's set these options on the database level. Now I'll create a table. This table is called file storage. And on this table file storage, I'm using the name folder ft. Folder ft. Let's take a note of all this. So folder ft. So I create the table. The table is created. If I query this table, mind, this table has no structure. I haven't gave fields for this table. Yeah, I haven't gave fields for this table because I'm defining this table as a file table. And once I'm defining this as a file table, it knows the structure that the table needs. So let's make a select on the file storage table, and we will discover that this file storage table is empty. There is nothing on this table. Okay, so what this does? Well, the file table we can access by using a UNC. And the name, then I use the name of my machine. My virtual machine is called workvm. And let's go with this. So I'm having here the name of the machine. I'll click OK. Oh, I typed it wrong. Sorry. I mistyped the name of the machine. Great. Workvm. There it is. Okay. So I typed the name of the machine and take a look. MS SQL Server. Yes, MS SQL Server. This is the name I defined it in SQL Server Configuration Manager as a share name for file tables. So I have a share called MS SQL Server. Let's go into this share. And I have file table. File table is the name that I defined for our database, DB test. Everything related to our DB test is inside file table. And inside file table, I have folder ft. This is the name defined for the table that I created, folder ft. So I have instance name, I share name inside the machine, then I have folders, file table, and folder ft. Everything mapped dynamically from SQL Server. So let's make things interesting. I have here somewhere where I put this. Oh, it's on F, Downunder, photos. Let's copy these pictures to our file share ft. So I'm just copying files, nothing else. I'm copying files to the folder, to the shared folder, to the UNC path that was defined by SQL Server. Okay. And so, what's the result? The result is that now, if I query again this table file storage, now what I'm seeing are the files that I just included in that UNC. So we can have a link between a SQL Server table and a UNC share in such a way that when a user on our company copies a file to inside the UNC share, we will have a new record in the table. So the table is linked to the content of that UNC share. We have some very special fields here inside this table. One of these fields is file string, and we can use methods over these fields. In many SQL versions ago, in SQL Server 2008, Microsoft created the concept of CLR. We could create classes and create types and objects inside SQL Server using .NET. So we started to see some objects using a more object-related syntax inside SQL Server. And in this example, I'm using methods over the field file string. For example, I'm using the method getFileName namespace path. So let's see what it will bring to me. In this case, is giving me the full UNC path to access these files. So it's easy to make an application work dynamically. If I move the SQL Server to another place, a simple backup restore will get all the files together, the backup and restore. And I can read the UNC, and SQL Server will always provide the correct UNC for my applications. If I don't use the parameters, I would be getting a relative path if I would like a relative path. And instead of getting the full path every time, I can get relative path and then read file table rules path, special functions for the file tables. So I'm reading here the file table rules path. Thank you. Sorry for the pronounce. I'm not sure if I'm pronouncing your name correctly. Thank you, Edge. Very good that the session was very helpful for you. Thank you. I'm showing just a few more details about the file table just to conclude this subject. And let's create some folders here. Folder 2, then inside folder 2, folder 3, folder 4, and inside folder 4, folder 5. That's it. So I'll get some of these files and move to inside folder 2. I don't believe that. I'm suffering of low disk space? No. There is quite a good amount of disk space. Now it's there. Then I move some files to folder 3. Some files to folder 4. And one file to folder 5. And the interesting part of this is the ability to deal with this hierarchy. For example, path locator is one field that the file storage table gives to us. We can get the level where this path is for each file. So we can see files that are on the first level, on the root folder, files on second level, on third level, and so on. So we can identify an hierarchy among the files. And here I'm reading get file namespace path, and I'm making a relationship with file storage to identify which files are inside folder 2. I'm using get ancestors to be sure that the ancestor is folder 2. I'm reading the files that are inside folder 2. So it brought to me folder 4, folder 3, and one image. The out of 10 are inside folder 2. But what if I would like on any level below folder 2? No, sorry. First, this other one is another way to achieve the same result. I'm seeing folder 2 and the items that are inside folder 2. Instead of using the get ancestor, I'm comparing the parent path locator with the path locator. Some tricks with the fields inside the file table. These are some tricks with the fields inside the file table. And is descendant of is another method that we can use, so I can get files that are on any level below one specific folder. So I'm getting all the files that are some level below the folder 2. That's quite interesting. And to complete these demonstrations, let's see what happens if I need to create further tables, regular SQL tables, and make some kind of relationship with the tables. That is my file table. First, the child file storage. I'll create a table child file storage with a reference relationship to file storage, string ID. String ID. It's just a bit too slower than I expected. I need to query the So, Bertus, do you have a question?
Yeah, while we wait, so is the SQL Server getting information from the operating system to create those records, or is it scanning those folders continuously?
Is a bit more complex than that. If you note the folder is not really a folder. It's a UNC path. I'm not accessing a physical folder in the OS. I'm accessing a UNC path. Usually, we are used to, we get a physical folder and we map the physical folder as a UNC path. And that's great. So what SQL Server did here is to hook on the network features of the operating system and created a UNC path where who is receiving the file is SQL Server. So when we copy some file inside this UNC path that appears for us to be a folder, is not a folder. The file is being copied to SQL Server.
Okay.
But at the same time, physically, the file never goes inside the MDF. The file goes to the file stream,
Yep.
to the file stream folder on the OS. But the user doesn't need to know that.
Okay.
So the
That makes
file
sense.
is arriving directly to SQL Server.
All right, I'll let you continue.
Okay, thank you. So file storage, let me get one string ID. Let's choose one file. Zakynthos 211. I'll get this string ID, I'll put this string ID here. What I'm doing, I'm inserting inside child file storage a record that will be related with that file, Zakynthos 211. So I'm inserting. And the table has a phone key pointing to that file. What happens if I try to go to the share? I try to get into the share. And here on the share, I try to delete this file. Delete. Yes. It deleted. It appears to have deleted. And this is terrible because I have a phone key pointing to this file. It couldn't delete this file. But let's see what really happens. Let's make it just I refresh. The file is here. SQL Server refused to delete the file. SQL Server received an order from the operating system to delete this file, but when SQL Server notes the phone key, it refused to delete the file because this file is related to records in the database. So I'm making a relationship between database records and the file in a share on the network. Okay. Let's change this a bit. Let me drop this table. I'll drop this child file storage table.
Sorry, just before you drop that, can you delete just one record out of that table? Will that then delete the file?
This example may be similar to what you are talking about. Let's see this example, then let's check your question. So while it's dropping the table, I copy this insert and make the same insert again on the new table. So it's slower than I was expecting. From drop or creating is lower than I was expecting. Okay, while it's dropping the table, I open a new query over the same database. Just for this to work, I will change the name of the table, put a 2 here. So I'll be creating the table again. Mind the difference. Now I'm setting the phone key to be delete cascade. The phone key now is a delete cascade phone key. So I'm creating the table again. There may be something wrong with my virtual machine because usually this should not take so long as it's taking now. Okay, this second example, we'll go ahead with the explanation, then get back when it's finished. This second example will cause a delete cascade effect. So when we delete the file, instead of blocking the deletion of the file, it will delete the record as well. So if a user goes to the folder and delete a file, the record referencing that file will be deleted. And after all this, another option also is to create another feature that we have. I can create a second table and I can create triggers over the file storage table. I can create triggers over the file table, and using these triggers, I can generate a result immediately when a file arrives in the file table. I can start a process from a trigger. And to make things even more interesting, in this trigger, I'm reading information from the sysdm exec session, so I can identify if the new file that I arrived in the share is coming from a copy, a user who copied the file inside the folder, or if it's coming from an application. An application could be inserting a record inside the file table and it will be stored in the folder. So there are two paths to insert records, copying file or inserting through application. And using a trigger, we can identify each file where that file came from, if that file was copied to the share or if an application have inserted the file into the table. It should not be taking so long. No, it should be taking so long. The create will only be done after the drop, but the drop seems to be blocked as well. Let me see if I stop the drop. Okay, let me try to create again. I'm creating the table with a different name. Let's see if it works better. Okay. It appears there is something blocking these executions. I'm sorry, so this makes a bit difficult to make these demonstrations. Let me see if at least the last one with the trigger can work. Another table is an isolated table. Then I create the trigger. I don't think so, but let's not exclude this possibility. It's possible. Yeah, it's possible that they were being blocked by my Explorer, but I believe this didn't happen in the past because it makes no sense if I'm using the UNC. If I were on the physical folder, it makes sense, but on the UNC, it didn't make much sense. But okay. So let me make the second test as well. Yeah, that's it. The Explorer Open was blocking everything. So the second test, now with the insert on child file storage. Okay, and this is the same file. This is the same file, but now the file is linked with on the delete cascade. Let's be sure that I dropped the previous table. Okay. So what's the demonstration here? The demonstration here is that for now I have select the star from child file storage 2. I have one record and this record is linked to a file on my UNC folder. Let's go to my UNC folder. And now I will try to delete this file. Delete. And now I make refresh and the file doesn't come back. Why? Because this time I'm using delete cascade. This time I'm using delete cascade. So if I select this, the content of this table again, the record disappeared. So I have a synchronization between the content of the folder and the records on the file table. And the last example is the trigger. I created another table and create a trigger to identify new files and insert the data into another table. So let me get some new files. I'll duplicate some files. Some files will be duplicated. Let's duplicate some files and insert them here. Let me try, just to be sure, let me get one that is not there. There's a Kintus 2 11, one file that is not there. Zakynthos to 11, that's it. Now, let's check. Select a star from another table. And is disk 0? The name of that field and the value that I'm inserting is reversed. Is disk 0, but in fact this means that it was inserted from the disk. Let's make an insert from SQL on file storage. I'm inserting a file from SQL. And now if I check the another table, again the second insert, and now it's 1. So 0 here means that the insert was done by the UNC, copying the file to the folder, and 1 means the insert was made by SQL Server using a simple insert to the table. So that's the demonstration. That's the idea. So we saw how varchar and text works and how we need to improve the performance of the varchar, setting one specific table option for that, and how we can solve the very long problem of where to store files inside the database or outside the database. SQL Server, since many versions ago, gave us a middle option, the file string. The file string, so SQL Server controls the storage, but it delegates the storage to the operating system. So this is the best of the both worlds. And if this was not enough, it gave us also the file table feature that allows us to control files and link files on a share to SQL Server data and records inside SQL Server. Any questions? Thank you very much. It's a pleasure to hear that you like the content.
While we have a few people typing into the chat window, I'd like to take this opportunity to thank Dennis for being part of this session this month and delivering to us about the tips on storing blobs into a database. I'd like to thank everybody for coming along and being part of this session. As I mentioned at the start of the session, it is being recorded and will be uploaded onto the Data Platform Downunder YouTube channel, where you can come back and view not just this session, but all sessions that we have so far this year, and for the number that we have already scheduled coming up. On that, for next month, we have, I shouldn't say next month, for next week. So if you haven't already registered, make sure that you do. We have Anupama Natarajan talking to us about tips to monitor your Azure SQL database. We are hosting 3 sessions a month, so make sure that you stay tuned and continue your learning throughout 2021.
So thank you very much. I leave to you my contacts here. I'm not sure if you can see my screen yet, but I put on the chat my contacts. And feel free to get in touch. It will be a pleasure to connect. And thank you very much and have a nice day.
Thanks, everybody. Thanks, Dennis.
Bye.
Bye.
Thanks, Travis. Cheers.
Thank you.